Okay, remainder theorem. Find f of negative 2. So obviously I could stick in negative 2 for x and find out the value of the function when x is negative 2. But they ask me to use the remainder theorem. So that means I should divide this polynomial. So 1x to the fourth minus 2x cubed, no x squareds, 1x minus 9, and I need to divide it by this negative 2. So bring the 1 down, multiply and add, multiply and add, multiply and add, multiply and add. This remainder is f of negative 2. So f of negative 2 is 21 by the remainder theorem. If you want to check, just put negative 2 in for x, and you should get 21. Okay, solve this equation given that minus 1 is one of the zeros. So that means that x plus 1 times by something is the same as this equation. So to find what this polynomial is, let me do the division, and I'm going to do it synthetically because that's the quickest way to do it. So 15x cubed, 14x squared, minus 3x's, minus 2. Don't need any placeholders. I need to divide by negative 1 because they tell me that will work. So if they were telling the truth, this should give me a 0 remainder. Let's see. Haha! Yes, it did. But not only did it work, as they said it would, but it also tells me what the other term needs to be, and that's 15x squared minus x minus 2. And now to find the zeros, there's 1 at negative 1, which they told me, but this term will give me another 0. It looks like kind of a nasty one to factor, so I might just want to use the quadratic formula. X equals negative b plus or minus the square root of b squared, which is 1, minus 4ac, which is plus 120, all over 2a, which is 30. So it's 1 plus or minus the square root of 121, which is 11 over 30. So the answers are 1 plus 11, which is 12 over 30, or 1 minus 11, which is negative 10 over 30, which is 2/5 or negative 1/3. So this quadratic was factorable, but it's okay. I've got all the answers. So the solutions are negative 1, 2/5, and negative 1/3.